electrification of vehicles must happen. Anybody who nowadays travel in Chennai, Bangalore, Pune, now Ahmedabad, Bombay, Delhi, if they travel 12 to 15 kilometers, they are starting to take an hour, 15 minutes, which means they will be spending 2.5 hours on road every day. And this is when our city population is only increasing. It's only going to get worse. We keep talking about future of India, next 25 years, next 100 years. Is this the future of India? Is anybody working on it? And if not, why not? Have we taken for granted that this cannot be solved? It will take an hour, 15 minutes. In about 10 years, maybe an hour and a half. I think this is a very, very big problem. Fossil fuel is certainly a big problem. We need to get rid of fossil fuel, but I consider this as a bigger problem. And we therefore need to solve this problem. Need a conceptually different transportation system. If we keep on doing fix here, there, it's not going to work. And my colleague is going to talk about what has been already tried.
So any good idea needs to start by looking at what has been done, right? We need to look at what's done and what has worked and what has not worked. And that's what we did. Globally speaking, traffic congestion is a huge problem. I mean, it's one of the burning problems. Every single person here is probably a victim of it, right? Every kind of a creative solution that has been tried globally falls under two themes. One is to add additional capacity. So you either build a new road or you widen the existing road, make more lanes so you can accommodate more traffic, or you can make the existing infrastructure more efficient. You can try different types of traffic signals. There are even AI-enabled traffic signaling now. There are ways to make multimodal transportation possible, but honestly, none of them have really fixed the problem. Traffic congestion is a perennial problem that has not been going away. It's only getting worse. You see a picture here, which is a route, Interstate 10. It's a 26-lane highway near Houston, Texas. And even then, the traffic during the peak hours is just obnoxious. It is simply not easy to travel even 5 miles within 30 minutes. And why is this happening, right? There is a concept called induced demand. When there's a product that is in high demand and you make more of it, of course the price is going to come down, and people are only want to use more of it, right? Same way, a lane is actually a pretty attractive product because you're getting more space to drive, you're saving time, you're going faster, so more people are going to be intending to drive rather than take mass transit. So a study in California found that any kind of major work that's been done, the efficiency goes on within 5 years. And what about the mass transit, right? Mass transit is helpful. It really helps with the environment. It pushes more traffic, but there are still problems because there are things called first mile and last mile. I'm not talking about the exact distance, but getting from your home to the origin destination, which is the closest mass transit location, and getting off from your train, metro, bus to get to your actual destination, maybe a work location, school, hospital, whatnot. The first mile and the last mile are a huge unknown. We just don't have a clear way of doing it. If you're lucky to live near those mass transit locations, then you're going to save time. If not, most of us are not, so it's going to take us a whole bunch of time. The problem is unreliability as well, because you cannot predict exactly how long it's going to take to go from one place to another, and it only gets worse during rain events, traffic incidents. If there's an accident, things go wrong.
And you know, the problem gets bad because it may not be that there is a single transport available between your home and office. So then you have to change, and then you have to wait. So you need a totally different solution. what we need, we have to dream, and we have to dream big. Dreaming big is the first step to solve a problem. So let's dream big. So what we are saying, we need a new solution which will be at least viable for the next 100 years. So what do we want to do? It must be a guaranteed 20-minute travel end-to-end from my home to office or office to home for up to 15 kilometers in any city. 15 kilometers, 20 minutes, no more than. And it must be fully green. It must only use therefore green electricity. Not anything else, not any other fossil fuel. Oh, sorry. It must also be highly energy efficient. You can't bring in, with the GHG emission going on, you can't bring in much more energy consuming. It has to be extreme energy efficient, in which case we rule out flying or this or that. It has to be on-ground solution. And as efficient as possible. It must be buildable in existing roads of existing cities. We can't say, oh, we'll demolish and do something else. It must be able to handle peak traffic. If 100,000 people travel in the peak hour, we must be able to cater to that. And it must be affordable. I'll sort of say for this, not more than that of a two-wheeler. Because most people in India won't be able to afford more. It has to be lower cost than metro and must be comfortable. And when I say affordable, it should take the total cost, infrastructure cost and operation cost, depreciation, interest, everything needs to be taken into account. Now, when you dream big, then it looks impossible. For quite some time, it looks impossible. And then gradually the solution starts coming. And solution that came here is what we call HASHTIC, high throughput, autonomous, sustainable human transport for India's next century. Now, why do congestion happens? Distances are only 15 kilometers. So it's not something we are not traveling 50 kilometers. But why does congestion happen? Congestion happens because there is a road in which we are moving and there is too much traffic on the road. Because there is too much traffic, as we have to therefore figure out a way that the roads don't get congested. What is the way for roads not to be congested? There are actually lots of small roads, thin roads. We don't take that. There are lanes. The reason is because traveling within that can become a problem. Two vehicles can get easily stuck. Somebody can park something. So we have to figure out a way to use the small lanes. That's only, then there are enough pathways. If I can use small lanes, there is enough pathway. Then the next reason for congestion is crossings. Every crossing, you wait. Earlier we used to wait 30 seconds, 60 seconds, now 90, 120, I have seen 210 seconds waiting. And more crossings are there, more you wait. So if you see, these are the two primary reasons. So what are we saying? First of all, we'll multiply roads by actually using existing thin roads. Number two, we will remove crossings completely. Now, in fact, those of you who live in Chennai and actually travel from here on OMR, if you see, they have come with a fairly nice road system in which there is no crossing. You can go and you have to turn. You only can turn left most of the time, that is no problem. Right turn is allowed at a certain point of time without. So I think basically we'll have to figure out some other system like this. What do we want? 15 kilometer, we say vehicles must move at 75 kilometer on the average. If they move 75 kilometer on the average, 15 kilometers can be traveled in 12 minutes. And that's where 12 minutes will become very important. We'll see this. You have to actually, once you get into a vehicle, you'll reach very close to your office in 12 minutes. So what are we talking about? We are talking about pods, very small pods. Half of a three-wheeler. Half of a three-wheeler. Two people can sit. Of course, there is no driver. It will be autonomous. Vehicle, personalized vehicle, maximum. They are narrow. Narrow is also very important. They must move on rails, not on roads. Why are we talking about moving on rail? What is the energy taken by a vehicle? It is taken by two things. One is the frictional resistance, and the rail friction is 1/10 of that of a road friction. Very simple. The second is aerodynamic resistance. As it goes higher speed, it pierces the air, and that is the second. So for the aerodynamic resistance, all the parts which move in this direction, in the same direction, must platoon with each other. They must join, virtual joining. So they're all traveling together. So the front one will get all the aerodynamic resistance, next one and next one will get less and less, very little. So the platooning becomes very important on the rail line. If there are 10 parts doing, only the front one is getting the full, rest are kind of joined. And we must power them using green electricity. That's we understand. This is the first level. It takes care of few things. It takes care of small vehicles. It takes care of, and this can be air-conditioned vehicle. It's no problem. Low frictional resistance, low energy, green energy, and using most energy efficient by platooning. Now, parts will travel on rail, and we will have rails. We'll have these rails either going left to right or right to left, and similarly north to south or south to north. Alternate roads will go north to south, south to north. So there will be plenty, and we'll talk about it, how this comes in. This is the kind of grid that we'll require. Basically, this kind of roads can be built on a big street or a very narrow street. Those of you who are used to this Kanagam road, very narrow road, this can easily be built on that. In fact, pretty much every narrow road, because even the vehicles are low, and we'll talk about how it is built, it is going to be built on north-south. And we are going to talk about this grid being about 700 meter by 700 meter. So roughly 700, and it need not be straight, it can be a little bit curving. But 700 by 700 meter, north-south or east-west, there are roads, alternate roads, vehicle move in one direction. Whether now suddenly wide street or narrow street does not matter, because vehicles will move like this. Now, this is going to be built on height. Now, the other interesting thing is east-west and north-south will be at two different heights. So there is no crossing. There is only a virtual crossing. There is no crossing. This can keep moving. This can keep moving. There is no crossing. There is no crossing. However, at every cross point, before any virtual crossing point, it can either exit or it can enter. It can enter. Entry and exit is allowed. Entry and exit is what we have to worry about. It can enter or exit, but there is no crossing. Entry and exit should not slow down too much. It will slow down a bit. We'll work this out, and otherwise it is going to continuously move. Now, there are two different heights, so there is no crossing. Links do not cross, only exit and link. And there are two stations at every cross point. There is one cross point station here, another station here. Two stations. At each cross point, there are two stations. We'll talk more about stations. And these are the stations whether you will alight or get up or get down. And there are two stations. In this 700 meter by 700 meter grid, there are 8 stations. These are all important. And congestion happens because of crossing and track switching. There is no track switching. Why? There is no crossing. There is only exit and entry. How do you make exit and entry without track switching is the next important challenge. We have crossed everything. In a rail line, there is any exit or entry will require track switching. If the thing moves straight or goes like this, there is a track switching. Track switching has to be avoided, because track switching will require heavy signaling, and signaling means you have to wait till all clear is there. All that has to be avoided. So parts in constant communication to a centralized controller. Now this centralized controller becomes very important, and an AI algorithm running at the will tell each pod how to go. So at the start of a journey, the pod will be told that this is where you have to go. It's end-to-end pod will go, and the journey map will be all entered. Now, as the pod goes, pod will go straight or turn. That's the only two possibility. What you ensure that at any time you are on a particular link, that when you are on a particular link can be all calculated in advance. You should ensure that no link is more than 20% occupied. If they are not occupied by more than 20%, there is no congestion on that link. If that link is more than 20% occupied, you find an alternate link. You don't do that. So ensure that no link is 20 to 25%, and pods are autonomous. Once route is downloaded, they will just move from end to end. Pods exit a link and enter to take a turn. And we also ensure that from end-to-end journey, there will not be more than 3 turns. Because any exit or entry will take us little bit of extra time, a few seconds extra. So that to avoid that, it must not take more than 3 turning. Stations on east-west and north-south at every crossing, there are 8 stations near you. What does it mean? Since there are 8 stations near you, once you get out of your home, on your mobile phone, you say where you have to go. And this mobile phone, then will say, walk to this station. This station will be around in 300 to 400 meters, and a pod will be waiting for you. A pod will be waiting for you at that station, and it will even give you the walking route. You walk not more than 3 to 4 minutes walk, because not more than 300 to 400 meters. So once you do get there, at the origin station, a pod is waiting for you. And pod is already marked that you will enter and it will get to that destination station. This is 3 to 4 minutes walk. This is not more than 12 minutes, and they exit also after that within 3 to 4 minutes. Since if you are in a place and there are 8 stations near you, doesn't matter, okay, one second. There are 8 stations near you. You know, wherever you are, you won't have to walk more than 300 to 400 meters. That's the trick. Whether you are exiting or entering, not more than 300 to 400 meters, and you will get there. And pods travel to destination station in 12 minutes. This is traveling at the average speed of 75 km per hour, peak speed of 100 km per hour, and essentially get you to there. Now, what we'll say, used 4 minutes to walk to the office. Typical network architecture, let's say a city of Chennai, 20 km by 20 km. You have 30 by 30 grid, 700 meters. So you have this 20 grid. And on all links, vehicles travel at same speed. Now, the other thing that happens that these are at roughly 2nd floor or 3rd floor height. Even the stations which are there at the corner, actually one of the existing building, 2 floor or 3 floor, you take a flat in that, something which has a lift, that will work as a station. So you don't have to build a new stations. You can lease out or buy out that flat. 2 stations at each node, east, west, and north side, located at the 3rd floor of existing buildings. So that's a trick. And pods are autonomous, tens of paths available between any place to any place. This is the key. And it has to avoid more than 3 turnings. And how do you go about doing it? If you look at it, suppose I have to go from this point out there. Well, I don't think this gives me very good. But that point there to this red point, the blue point to red point. Of course, one route is this, as I showed you. The other route could be this one. 3rd route can be this one. 4th route can be this one. And in a 15-kilometer kind of journey, in a 12-kilometer journey, you can find 20 to 30 possible routes. Most of them are equidistant. Some will take 1 or 2 extra links. Now, this is where the AI algorithm will come. It will figure out all the possible routes, find out if it takes this route, how much is it congesting a link. At that time, it will reach that link. How many vehicles are already there on that link? And when it exits it, it will freeze that. So it computes it and ensures it calculates the route weights for each link and makes sure that it chooses the route which is the most optimal. This is critical. So some innovations. The routing is first innovations in this. Pods determined by a central AI system, and typically there is a station. Out here I'm showing one stations which can go this side and that side. You can actually have two stations, do it even more. And the stations, you can turn from the station or you can directly turn. This is what pods can go straight or exit at any cross point. The second innovation is pods move on rails on narrow as well as wide street. Because they move on narrow at the same speed as wide street, there is no particular reason that you need to take OMR highway. Kanagam road or any Velacheri road is equally good, or even the small lanes between them are equally good. Ability to block any part of the network. Suppose this network is there and something goes wrong at any of the station or any link, something goes wrong. Just block that path and reroute all the traffic. You block that particular path, a section will be blocked, no vehicle will enter that, no way, and gradually you evacuate and fix that particular thing. So that in case of accident, failure, maintenance, all pods on that will be routed. The next innovation, extremely important innovation, tracks are fixed. There is no track switching like the one that takes place in railways. Now if the tracks are fixed, it is like your car. The car will turn. Now on the rail, how do you turn? So this is where we have done a fairly interesting patent pending technique. A pod can go straight or can exit. Pod decide to actuate a lever to go straight or exit as per downloadable route. So near the cross point, there are two guideways which will either take you straight or will take you the other side. And this is where a catcher is used which can make it turn, go straight and that.
And Professor, another advantage of keeping the infrastructure static, there are no moving parts, right? It's a bridge and there's going to be rails and no moving parts, the guideways. The only moving parts are in the pod. Moving parts go bad quicker than the static ones, right? So we are targeting maintenance on the pods and keeping the maintenance lightweight on the whole infrastructure, making it kind of easier to operate the whole system. Another advantage of segregating the people transport and goods transport is that traffic engineering statistics says that, let's say you have a place of origin in Nagpur and you need to bring goods to Chennai, 90% of the journey, they only spend 60% of the cost and time. The last mile, as we say it, in the urban traffic congestion, they have to spend more than 40% of the cost and time because of all the vehicles in here. By taking the people, most of the people transport on a different level, we're actually bringing down the cost of the goods as well. So we're solving two problems, kind of a win-win solution.
So what did we do? We did a full simulation. We took Chennai as an example. We took a 30 by 30 grid in 20 kilometer by 20 kilometer region. We calculated that in a peak hour, we can do 3.6 lakh travels from any place to any place. And in Chennai today, we got some estimate about in a peak hour, 1.5 to 2 lakhs people travel. And here remember that two people can go in single pod. Of course, if they are going from same source to same destination and at the same time. So if they're traveling together, it gives you an advantage. So this is what, in a day, we are typically looking at 2.5 million pod trips per day, which is about 6 times more than the total traffic today in Chennai. So this is the kind of capacity that we have, and pods can accommodate 1 to 2 passengers, so it actually can be more. Finally, we also have ability that if you have a 700 meter by 700 meter grid, but some area, some locality, Tinagar is highly densely populated, and you need more there. Well, you make it 350 by 350 meter. Take a 700 meter by 700 meter, and you divide it by 2. One this side, one that side. You create in a locality, smaller region, more such links, and you can actually handle that. Then, so what do we do? Overcoming 2 hour plus hour of home traffic, target time, and actually we are not just doing it For the sake of doing it, we did two things. We did a full simulation. We actually calculated the cost. We had civil engineer estimating. This is all estimate, cost of construction, cost of pods, cost of the complete transportation system, everything we actually did. And we have also started building a prototype. Prototype is today very first level prototype. Scaled prototype is available in this build complex in the A block on 7th floor. At any time, our volunteers can take you and show you that. It's a very first prototype. I think it will take another 6 months for us to perfect that, and then we'll go for a full-fledged model in some places. The most important thing, we computed the cost. This time the cost of the infrastructure included. Normally, road cost is never included in the transport cost. But we included it. Suppose I have to build it in a place like Chennai completely, and this is the journey, this is the number of people who travel. We estimated that, and the cost is less than that of a two-wheeler. Per kilometer, cost is less than that of a two-wheeler. So that's a kind of thing that we have actually worked it out. And however, I want to move very quickly to one more problem. With a very similar concept and yet very different, we are trying to look at one more big transport problem. There are two big transport problems other than electrification. One is city congestion, other is what about goods movement across the country. Goods on the average today from Chennai to Amritsar takes 5 days. It's a 3,000 kilometer by roughly about 3,000 kilometer by 3,000 kilometer. Total distance, north-south is 3,000, east-west is there. So the travel distances can be closer to 3,000–4,000 kilometer. And in this, today's traffic takes goods transport by trucks. Ashok Leyland can electrify its electric trucks and make it electric trucks. It will take 5 days. Does railway help? No, railway takes even longer time. Now this is at the current goods level. If our economy grows as is being thought of in next 25 years, amount of goods transport will go up by 7 to 8 times. How are you going to carry it? And that's where a very similar concept, but yet very different, is being planned. It must be sustainable, green electricity alone. We said nothing other than green electricity. Energy efficient. It must travel on rail rather than road. To overcome the aerodynamic resistance, it must platoon. All these are similar concept. Minimize travel time, zero congestion network. No road will ever carry more than 20% of its capacity, 20–25% of its capacity. No crossing, end-to-end transport less than 24 hours. And centrally controlled autonomous carriage movement. Controller determines route for each carriage as a journey begins. Autonomous carriage movement on chosen route. Similar concept and yet very different. So we are talking about 100 kilometers is on electric trucks. These can be Ashok Leyland trucks. All the goods are being carried by a container, in a container. So you move a container from an electric truck to this carriage. Just move that, and this carriage will go from Chennai to Chandigarh. Last 30–40 kilometers it can go by road. So this is the kind of concept that we have for something like this. HASHTIC is possible, leveraging innovations that I'm saying. It's a very tough problem. There will be enough problems. If the introduction of electric vehicle, people are worried about battery catching fire, there will be 20 such problems coming up. Of course, anything new, we often forget when the petrol cars were first introduced, there are lots and lots of fires. But it's a matter of 3–4 years, 5 years that we overcome. Petrol has more energy density than electrical battery. Petrol can catch fire much more easily. We learn to overcome that. Same thing we'll do for battery. Same thing, any problem that comes here, we'll be able to solve that. Will be highly energy efficient, can be built on existing cities, total cost less than that of a two-wheelers, need the will. We have formed a port transport forum of India. which consists of multiple startups and researchers from around the country to sort of say, we will solve this problem. Now, is it going to be exactly this problem? Are there going to be 10 modifications? Will it completely change around? Let it happen. The important thing is it must work. It must not violate any of the principles that we said. Completely green, least energy, and time taken cannot be violated. We can find any other solution. We'll be happy to work on that and build it. We need it in India, and the world, many countries in the world needs it. Congestion problem is not just there here in India. We need to build and take the leadership in the country and then take it all over the world.